Hi, today in this video, I'm going to talk about X bar chart and R chart. Some adverse factors like machine wearing out or the machine which is adjusted in such a manner to produce quality products, that adjustment when gets out of order or when raw material that was purchased to produce the output, produce the good is actually defective, or sometimes when the labor force that is working to produce the good made some errors. And because of those errors, the quality of product, the output, gets affected. Now, there are certain procedures that are called statistical process control are available for monitoring production output so that poor quality can be detected easily and the production process can be adjusted or corrected. Now, if the variation in the quality of the production output is due to assignable cause, so there are two causes. There are two causes that actually affect the quality of output. One is called assignable cause. What is this assignable cause? Assignable cause are those causes like machine wearing out or the machine adjustments getting out of order or the raw material when raw material is what you call defective. Raw material is defective or because of some human error or the error by the labor force. When these factors, these causes actually lead to the poor quality of output, then that causes are called assignable causes. The second one, the second type of causes is called common causes. These common causes are mainly because of some environmental factors like temperature, humidity, or some of the other causes that actually leading to the poor quality of product. Now we can see that assignable causes, if detected early, then in that case, these mistakes, this poor quality can be corrected or that can be adjusted. Whereas common causes are because of environmental natural causes, then these type of causes cannot be adjusted or corrected. So the main focus is to check the assignable causes. Now, the main these causes, detecting these causes and then using correcting measures. Now, detecting these causes are actually possible through statistical procedural control. And the main objective of statistical process control is to determine whether variation in output are due to these assignable causes or these common causes. Whenever these assignable causes are detected, we can conclude that the process is out of control, and in that case, corrective actions would be required to be taken to bring the process back to an acceptable level of quality. But if the variation in the output of production process is mainly due to common causes, we conclude that the process is in statistical control or simply in control. And in such cases, there is no changes or adjustments are required in the process, production process. So what is done then? When it is found that whether it is from the assignable causes or whether it is from the common causes. To check it, what is being done is what can be done is like we create two type of hypothesis. One is null hypothesis and the other is what you call it alternative hypothesis. The null hypothesis formulates in terms of production process being in control. This means that the production process is in control and the causes the quality problem is mainly occurring due to common causes. So the null hypothesis formulates the term that the production process is in control, whereas the alternative hypothesis formulates in terms of the production process that it is in out of control. So the first one is null hypothesis, and that is called H0. Here, H0 says that the production process is in control, and the alternative hypothesis, that is HA, says that the production process is out of control. Now, these two hypotheses is actually created, and then the statistical tests are done on those hypotheses to find out which hypothesis holds and what is the final conclusion. Now, that was through null and alternative hypothesis. Now, there is another method that is called control charts. That's what I'm going to talk about now. And these control charts are X bar chart, R chart, P chart, and NP chart. There are four different type of actually control charts. So let's first start with a control chart provides the basis for detecting. Let me write it down here. What is a control chart? So a control chart provides the basis for detecting whether the variation in the output is due to the common causes or the assignable causes. Okay. Whenever an out of control situation is detected, adjustments or other corrective actions are taken to bring the process back into the control. So these control charts can be classified by the type of data they contain. So first one is X bar chart. So what does the X bar chart do? X bar chart is measured in terms of variables such as length, weight, temperature, and so on. So, X bar chart measured in terms of variables such as length, weight, temperature, and so on. Whereas the R chart, what does it do is it is used to monitor the range of measurement, range of measurement in the sample. Okay. Similarly, there are P charts that detects the proportion of defective and NP chart that actually detects the number of defective items in the sample. So these were type of control charts. Now I will talk in detail about the X bar chart. The X bar chart looks like this. This would measure sample mean. So that would measure sample mean. And this line is actually called process mean. That means the population mean. Generally, it says population mean, but the population here is a total process. So the process mean. Okay. And then there are two control limits. One is upper control limit and the other is lower control limit. This is called upper control limit, and this is lower control limit. Now, as we know, X chart is used if the quality of output of the process is measured in terms of variables such as length, as I told you, temperature, weights, and so on. In that case, the decision to continue or to adjust the production process will be based on the mean value found in the sample of the output. Okay, so the center line, this line of the chart corresponds to the mean of the process when the process is in control. So when the process is in control, the chart would be like would be here and that on the process mean line. Okay, the two lines, that is UCL and LCL, are important in determining whether the process is getting out of control or not. The lines are called the upper control limit and the lower control limit, as I told you. Now, there are two ways to calculate this upper control limit, process mean, and lower control limits. Process mean is generally equal to the population mean. So that would be equal to, if you calculate the sample, the mean of it is actually the process mean. And there are two ways to find out the standard deviation to calculate the upper control limit and the lower control limit for this X bar chart. One method is if the standard deviation this is known. When this standard deviation is known in advance, that this means that if the standard deviation of the process control is already known, then in that case, the first thing that you have to calculate is to find out the standard error for the sample mean that you have collected. So calculate the standard error, and that standard error is called, okay, and that is the standard deviation of the process control of the process divided by root of n. Here, n is actually the number of samples that has been taken. So, where this one is process standard deviation and n is actually number of samples taken. Okay. So once the standard deviation is calculated, then based on that you can find out the upper control limit and lower control limit. I will give you the formula to calculate the upper control limit and the lower control limit. So let me write down the formula. The formula for the upper control limit is UCL equal to mu. Mu is the mean of the process plus 3 standard deviation or 3 standard error you call it. So it would be 3 x bar. Or you can also write it like mu plus 3 multiplied by this value, standard deviation of process divided by root over n. So this is the formula to calculate the upper control limit. For the lower control limit, you can use this formula as mu minus 3 standard deviation x bar, or that is equal to mu minus standard deviation by root n. 3 standard deviation root n. So using these two formulas, you can calculate the upper control limit and the lower control limit for the x bar chart if the standard deviation is known. Now, what if the standard deviation is not known? Now, let me write down what if. Second is if the standard deviation is not known. What if the standard deviation is not known? Then first of all, we need to calculate the standard deviation or the estimator of the standard deviation. How can we calculate it? There is a formula to calculate the standard estimator of standard deviation or standard deviation of the process, and that formula is this is equal to R bar divided by D2. Now, what is R bar? When you have taken a sample, you have taken, if you taken first sample, there are n number of samples you have taken, and for each sample you have taken some observations. Now, for each sample, the lowest and the highest, if there are 4 or 5 observations taken for each sample, then the lowest value and the highest, the difference between the lowest value and the highest value, that is the range of that particular sample, is called R. Okay, so R is actually range of the sample. Now, when you calculate the range of the all the samples and then take average of R, the average of the range, then that is called R bar. So here standard deviation that we are going to calculate and it is not known, then you can use this formula that standard deviation is equal to R bar divided by D2. What is D2? D2 is constant. D2, A2, D3, capital D3 and capital D4 are actually constant, and the American Society for Testing and Materials Manual on Presentation of Data and Control Chart Analysis actually provides the value of these factors, these constant factors D2, D2, A2, D3, D3, and D4. These are constant factors, and the data for these factors and for different level of samples are actually given or provided by the American Society for testing and materials on presentation of data and control chart analysis. So they provide these constant value data. When you have already have this data for different n number of samples, if you have n samples, then you need to check the table that is provided by this society, and from that table you actually find out the d value for your given number of samples, and then divide the mean range by this d2 to find out the standard deviation of the process. When you calculate the standard deviation of the process, then use the same formula for to calculate the UCL and the LCL. Now, let me give you the formulas for UCL and LCL. So UCL, that is upper control limit, becomes, now look, because we don't have the standard deviation and we don't have the popular process mean. So in that case, what we'll do, we will take the average of all the samples and then calculate the mean. So that mean is called X bar. X bar is sample mean. So we first calculate the sample mean of entire sample, and then we calculate the standard deviation of the process by using this formula, and then use both of the values to find out the upper control limit and the lower control limit. The upper control limit would be, so UCL is equal to X bar, then plus 3 standard deviation, 3 standard deviation we call it, and that is this by root over n. We know that, right? From last one. But now, when we use this formula to calculate the standard deviation, then this becomes x bar plus 3 multiplied by r bar by 2 divided by root over n. Similarly, UCL, LCL would be like x bar minus 3 standard deviation divided by root n, and that is equal to x bar minus 3 multiplied by r bar divided by d2, and that divided by root over n. So using this formula, if the standard deviation is not known, then in that case you first calculate the range of each sample. After calculating the range of each sample, then for each sample, then what you do, you actually calculate the average of the entire sample, average range of the entire sample, and then using D2 from the society, the American Society for Testing and Materials Manual on Presentation of Data and Control Chart Analysis, they provide the data of D2, A2, D3, capital D3 and capital D4, these are constants. These are constants that are used for finding out the control limits of different production process. So you can get the data from there for your number of samples, and then you can find out the standard deviation. Using this standard deviation, you can calculate the upper limit, upper control limit, and lower control limit of the production process. Whenever the sample mean goes out of this area, then that means the production process is out of control and requires correction and adjustments. Either it goes up or it goes down. In both the cases, this requires adjustment. If it remains within this limit, this means that these fluctuations that is happening because of those control causes. Okay, if it goes out of this limit, that means this fluctuate this process going out of control is mainly because of those assignable causes. Okay, now this was X bar chart. Now I'm going to talk about R chart. R, we already know R is actually range of each sample. Now, how to get a chart out of that? R chart is similar like X bar chart. Okay, so now I'm going to talk about R chart. R chart is also called the range chart that can be used to control the variability of the process. To develop the R chart, we need to think of the range of a sample as a random variable with its own mean and standard deviation. Okay, so the samples have their own mean. The range of the sample, each sample has a range because we are taking different observations for each samples, and then based on their lowest and highest value, we are calculating the range for each samples. Now, what is assumed that the range of each sample is actually normally distributed, and they follow steps, simple random sample. I mean, they are random variables, okay, and they have their own mean and standard deviation. So, first of all, what will be done? We will be calculating the mean of those ranges, and that mean is called R bar. So, R bar is the mean of range of each sample. Okay. Now, when mean is known, now we'll be calculating the standard deviation again to find out the upper and lower limit of the chart. Okay. So the standard deviation can be calculated by using this formula. XR mean is equal to D3 multiplied by R bar divided by D2. Now D3 and D2 are constant, and that you can find out from the table that is provided by the society. From that table, you can find out the constant value of D3 and D2. R bar you can calculate by taking mean of ranges of each samples. When you get this value, then you can use the formula to find out the upper control limit and the lower control limit of your range chart. Range chart would be similar like the X bar chart, but here instead of mean, we are using the mean of the range. Earlier, we were using the mean of the samples. Okay, and then for each sample, we calculated the mean, and that central line was the actually process mean process. Whereas here, the central line would be the mean of range for each sample. And then upper control limit and lower control limits will be given whenever the person process fluctuates between upper control limit and lower control limit. Then this is because of the control causes, and if it goes out of those bounds that is given, then this is because of assignable causes. So the formula for UCL in R chart is equal to R bar plus free standard deviation, or you call it expected standard deviation of R because we are getting it from the sample, So this is the expected standard deviation for the range R bar. Or you can write it as this one, R bar equal to 3, R bar plus 3 D3 R bar by D2. When we take R bar common, it becomes R bar 1 plus 3 D3 divided by D2. So this is the formula to find out the UCL. Now I'll be writing out the formula to find out the LCL lower control limit for R chart. So the lower control limit would be R bar minus 3